This video will tell you a little bit about the histogram function in Prism. And we've got an image up on the screen, so we'll go to Histogram, select Global, and we're now presented with a graph which shows us the distribution of pixels. And this shows you how many pixels are in each particular value within the image. And they start at a minimum value of 211, which would be down on the far corner. And the pixels with the highest value are up here, and that's about 58,004. So that's the range of pixel values within our image. The graph itself shows you the frequency that they occur. So in this case, we have almost 4,000 of them up at this particular point. The question, of course, is what is exactly that value? Because we don't have a detailed scale here, but by using the cursor and clicking on it, we get a yellow line, which then tells us what the value is at that particular point. And that happens to be a pixel value of 45,374. The next number is the hexadecimal equivalent of that, and I suggest you ignore it because it's really for camera designers and professional astronomers validating their camera data, as is the binary value that's down below. What is important is that particular pixel value, we know we have 4,103 pixels scattered across the image. And we know that there's 23% of the values or pixels in the image that have that particular value. In other words, starting from the beginning all the way up to that point. And we actually have the total number of pixels involved both up to that point and beyond that point. So we have roughly 1.4 million pixels in this region, and we have about 4.8 million pixels in the other half. We can click, of course, anywhere on the image to kind of see where the cutoff point is. So if we go right up at the beginning here, this is likely just a bunch of cool pixels that probably aren't carrying a whole lot of data, and there's roughly 1,083 of them from the beginning up to that particular point. You can always look here to see exactly what the max and min represented in the graph are. We have the ability of moving the histogram around by using the arrow keys. So now we change the range, so we're going all the way up to 69,000 and starting at 11,000. We can go back again. We can also adjust it by using the up and down buttons and the step increment. We can change that, of course, to a larger or smaller number. And that gives us the capability of examining on a more detailed basis. The zoom in and zoom out buttons allow us to zoom right in on the particular histogram values we're interested in. As you can see here, we get a very close-up view. We also have the ability of changing the overall graph format. So let me just zoom out like that. And let's say we really just want to look at this particular region here. So if I click on that value, which is 42,708, and I use the downward arrow key, then it will align the graph so that it starts at that point now. So our minimum is now about 42,000, and then the rest of the graph is present. And I may not be too interested in the rest of this tail here, which are the very hot pixels. So let's say I click on that particular point and I use this down arrow key. It's going to align the graph to that maximum value. And so we can tailor the min and max very easily by just clicking on the image and then using those down arrow keys to select it. If at any point we get lost, we can always use the reset function to go back to where the image of the histogram originally started. The log scale is used because the most effective representation, I would say, is really with a logarithmic scale. If you go to a linear scale, you get a very skewed view, so that's why we tend to use the log scale all the time. Now, one of the other convenient features of this is the ability of putting in a threshold function to be able to examine parts of the image. So if I set this as the low threshold value, and we go back to the image here, in red you'll see the areas of the image that are below that value. So there you go, that gives you an idea. And this is just some uncorrected vignetting primarily in this image that we're seeing there. Similarly, if I use, and it's a binary function, so right now it's turned on. If I click that, it goes off again. Similarly, I can do a high threshold, and let's say we want to look at the brightest pixels, then I just hit high threshold, and it shows us the cores of the stars as being the brightest pixels in the particular image, and they all have values of 49,946 or above. The intensity function is useful primarily in bias frames, dark frames, because it will actually, let me just turn off the high threshold first, it will actually turn red all the pixels of a particular value. And because we only have, in this case, 4 pixels, we'd have to go hunting to find those in this image. But it is useful in a bias frame where there's a very large distribution of pixels in a fairly small number of values. Now we also have another capability over here, which is the clip low and clip high. So we can actually get rid of a bunch of pixels down at the bottom end. And clip low will basically clip those out of the image. And you can see it did nothing to the image itself because those were likely inactive pixels to begin with. We have to be careful on the other end though. If we were to click up here and click high, it's going to eliminate those, and those are basically the hottest parts of those cores of the stars, and so I don't advise that unless you have a very specific need to do that. You can also save that information, which is basically a complete list of all the pixel values. It's basically a text file that lists all the different values of the pixels and their frequency, and you can also create a plot. That plot is only a linear plot, so I don't think you'll find that as useful as the plot that you have on the normal display. One other capability that we have is the ability of defining cold pixel thresholds. So for example, if I want to say, gee, all these pixels below this level, I'd like to view those as cold pixels, I can do that. And I can specify that, yeah, we got a few hot pixels here, and let's say the top 231 are hot pixels, define that as the threshold. It's now available to be saved as a list, and when we do that save, this file name that we're going to put in here is going to be saved not as a text file, but rather as a cosmetic script file that can be used in our cosmetic processing function within Prism, so that we can just say yes to that, and we can then use that to process an image to get rid of hot pixels or cold pixels as required. And the save function also tells us that 2,333 pixels were actually saved. You can also view the graph in either a bar format, which is our normal format, or you can put it into a linear format. Personally, I prefer it in the bar format myself. I find that more useful. So hopefully that gives you a little bit more detail as to how to use the histogram functions. And of course, if you have any questions, please use our forum and we'll be glad to answer them. Thanks.